What language are we even in?
And that is going to...
Sounds kind of English to me. Alright, we're back in English. Welcome back to this advertisement stream. We are live. I guess. I don't know. Let me check. Are we live? No, not yet. The delay is too big. Okay, so welcome to this advertisement stream for Lasergurkenland. I should probably look into like streaming overlays where I can put like 90% of the screen, just the IP address of the server, so I maximize my advertisement game, but whatever, just, yeah. I guess people will know to check the description for the IP address, which, by the way, is lgl.sillyhun.com. Join now, donate now, buy my products, invite all your friends, like, share and subscribe on Twitter, Instagram and Facebook, the official Lasergurkenland server. It's great stuff. It's anarchy. It's free. Yeah, I don't know, it's empty. Well, we have actually players online, but come and bring your gang and we have some fun. Oh, I wanted to make pistons. I thought I will forget that, but I didn't. I'm such a surprise to myself. Okay, so, yeah, today we are going to check out a new YouTube channel. Will you believe it? It is the channel PDX Node. I've never watched a video from this channel, but the guy has a DuckDuckGo t-shirt, which, well, is reason enough to check it out. Yes, so the video title is The Peer-to-Peer Web by Paul Frazee. And as always, I have no idea how to pronounce his name, but I like the letters, Frazee. Doesn't that look cool? I think that's a great name. Yeah, so PDX Node, a small channel with 298 subscribers at the moment in 2020. The video is from 2017. It has 7,000 views, but I found it through a re-upload from Coding Tag, which is this like YouTube channel that just re-uploads all these talks, and I think it has even more clicks there. But I like to support the original, which, by the way, you should do as well. So if you're actually interested in the talk that I'm playing back in the background, make sure to check out the description where I link the original talk, and then you can give a click to the original author of 90% of the content of this video, which is kind of fair in my opinion. So make sure to do that and give him some clicks and likes and whatnot, and I feel better stealing his content. Cool. So then I would say, if we have that out of the way, we can start creating the video. Anything left to say? Don't think so. Wait, I quickly want to finish the pistons and repair my elytra, so my mind is open for input. Is it? Oh, it's the other way around, right? Open for input, so I don't, yeah. Am I doing something? Is something wrong here? Didn't I? Can help. Oh my gosh. Okay, so that's enough. And then I want to quickly do that and repair my elytra. Yeah, that's how you repair. You just exchange. Good mending elytra. Yeah, whatever. So okay, I guess that's it. Then I would say let's go and start the video. As I said, check the original in the description. It's a 1 hour video, it's 53 minutes, and as long as the video will take us to watch, as long the stream will be. Yeah, but please check out Lasergurkenland. It's a great server. It has no world resets and it won't go anywhere in the next few years. So that's great. and you're allowed to use hacked clients and there's no anti-cheat. Isn't that great? Well, for some people that's a feature, for some people that's a no-go. But I don't care what you want, because deep down you don't even know, but you really want to play on the server, right? It's not something that your actual active mind realizes, but deep down the pure sense of your whole life craves to play on Lasergurkenland and enslave yourself to play infinitively and invest all your power in strengthening the server. But maybe you don't realize that. At some point you will. Yeah, my selling strategies get more desperate every stream, but yeah, well, I guess we just keep going and just play the video. What is Hashbase? Is it some GPG thingy?
Alright, so my name is Paul Frazee. The name of my talk is
Frazee.
Peer-to-Peer Web. Excited to be here talking to you all today. I work together with Tara Bansel. Together we form Blue Link Labs. We're based in Austin, Texas. And the name of our project is the Beaker browser. And it's an experimental peer-to-peer web browser. That's what I'm going to be talking to you all about today.
Why do I
So
have
to
the
get into
feeling
this,
that
let's talk a
Beaker
little bit
web
about the basics.
browser? I think I know that browser. Beaker. I think I've seen her talk about this already. Beaker browser. Yeah, it has this blue logo, doesn't ring a bell. I think I've looked into that for like 10 minutes. Copyright 2018, nice. I think I've seen a talk from, but not from him. I think it was a girl talking about it. Very passionate. If I'm not mistaken, I might be mistaken, but I think I've seen a talk about this browser from a female speaker. Well, I don't know. Let's go start it. I think I haven't seen that video already.
So to get into this, let's talk a little bit about the basics of how the web works. Going really back to the initial conception of the web, in its most basic form, the web is a way to publish documents. All right. So if I wanted to publish a document, what I would do is upload it to a web server. And then that server is going to host it and distribute it out to my audience, right? And that's the publishing flow. Now, of course, the big deal with the web early on was the fact that you linked from document to document, right? With the hypertext, that's the big idea. The server was just sort of an implementation detail. It's how we did it, but that wasn't necessarily the key of this thing. The key was that it was the web. Documents linked to each other, and without a complex top-down hierarchy, it can be a free and open publishing platform. All right, and that worked pretty well, and it got popular. And after a while, we started want to do things that we couldn't do originally on the web. We wanted to have things like Wikipedia, where you could edit the page in line. We wanted to have things like Twitter, where you could put little status updates out, right? So to deal with that, we started to put application code. And I think my computer's frozen. Give me a second. There we go. Started to put our application code into the server. And along with that application code, we began to put databases onto the server. Right? And this is how we began to have more dynamic behaviors on the web. And we moved away from the Web 1.0 conception of documents and links to the Web 2.0 idea, which is that we're going to have rich applications running on top of the web platform. But these applications live in the server. Your application code, your database, your source of truth, all going to exist inside the server. And these computers, with their web browsers, are what you call a thin client. They're just rendering a UI. And the core of that application is up on the server. Now the good thing is that works really well. The cloud has been, in a lot of ways, an enormous step forward for computing, both for developers and for end users. Everybody benefits from the fact that it is always available. These servers are kept online all the time. They're managed centrally, and they update automatically, right? So you don't have to go and update individual computers. Everybody's just on the same page. Handles a lot of data, scales up really well. As an end user, I don't need to worry about synchronizing my devices or losing a hard drive because I can just reconnect to my account on a new device. There are a lot of benefits to the cloud. So we got to the point where we started to say, well, you know what, let's just do everything this way, right? So here we are now with these enormous servers up at the top. And it's gotten to the point that if you're going to do something that even in its nature is a peer-to-peer transaction, like for instance, sending a file from one computer to the other, well, how are you going to do it? Well, of course, you're going to use a service, right? You're going to stick it on Dropbox or Google Drive, and that's how you're going to get the file over to somebody. So we have what I would call an architectural monoculture. Everything is done client-server, regardless of the actual needs of your application. All right, well, what's the problem? If it works, it works. What's the big deal? Well, first of all, the answer to that can't just be that you don't like Facebook. Politics are a good reason to set yourself out on a project, but you actually need to have deliverables, right? What are we trying to fix? Well, if you talk to web users nowadays, probably the number one thing they'll say about the web, if you're asking them what they don't like about it, is that it's a little bit creepy and that you don't own your data. You don't own your network. Now, let's drill into these individually. First of all, for whatever reason, the web has never evolved a way for users to send information from one device to another with complete end-to-end secrecy. If you're really advanced, you can figure it out using something like PGP, but for the most part, all the data we send goes in the clear through a third party. So we're talking about emails, and we're talking about documents, we're talking about office information, right? Intellectual property is going into the cloud, and in a lot of cases, it's sitting in a warehouse somewhere in plain text. Now, a part of our obligation as software engineers is to protect users' data. And in that regard, we're not doing a great job. This is a security limitation in the way that we're doing things, and we ought to move past it. There's also an element of a lack of trust, I think, that this sets. Because users at this point are accustomed to the fact that they expect to have their data mined. And that is going to eventually cause our user base to lose trust in what we do. And that is just something that we should not allow. All right, next problem, lack of modifiability. So show of hands, who here recently has had a pull request merged into Facebook? Nobody, right? You can't do it. The lack of end-user modifiability.
Well, Facebook has some open source repositories.
Is a
but
freeze
not all
on
of
the
it.
amount of innovation
Yeah, sure.
we can use or put into work on the web, right? If users can't solve their own problems, then they're going to have to wait for companies to do it for them. There's not a whole lot of a fine-grained control about what your experience is like on Facebook. Everybody gets the same thing, all right? So we're losing opportunities to do interesting things or to make decisions for ourselves. I'm a hacker. I want to be able to edit my source code. Somewhat complementary to that is a lack of ownership of your actual data. All of the data is being stored into a database in somebody's server. So even if I did have all the source code to Facebook and I deployed it on some server somewhere, I still wouldn't be able to message my friends or send out a friend request or see their feeds because actually all of Facebook is stored on the internal data structures and the internal data networks of Facebook. Right? It's not a federated system. So they would have to completely re-architect to support that, and they're not going to. And so users lack ownership of their data, they lack ownership of their networks, and they lack ownership of their code. So why talk about getting away from the client-server monoculture? The reason is that we can improve the privacy of the web, and we can also improve the ownership of the online experience for people. Now, talking about this a little more dryly, and specifically, you could say it's an architectural deficiency. We've put a whole lot of work into making the client-server model work really well. Tons of resources, and it's been doing a great job. But the peer-to-peer story on the web is pretty anemic. Now, broadly speaking, you can think of the web as an application platform for networked applications. right? If you're going to have a lot of users working together, you use the web. And so it would make sense that we have not just one design for how our networking is done, but some flexibility in this. That not only can you do client-server, but you can also have peer-to-peer architectures, or even better, a hybrid of the two to match exactly what you're trying to accomplish with your application. So we want some flexibility in how this is done. All right, so that's the why. That's where we're coming from with this project. Let's talk about what we've actually been doing. Broadly speaking, the mandate has been, if we integrate peer-to-peer networking into the web, what do we get out of it? What kind of features can we start to stick into the browser? And so what we've done is we've taken Electron, which is basically a wrapper around Chromium, and used that to create our own fork of Chrome. We're not the only people doing this right now. Brave is a browser that's pretty well known. That's run by Brendan Ike, exact same story. There's a couple others as well. But for us, the focus is on a specific kind of peer-to-peer networking. Now, we're not talking about WebRTC, and we're not talking about blockchains. The kind of peer-to-peer network we're using is a variation of BitTorrent. And it's called the DAT project. All right? It's very similar to BitTorrent. It's like a BitTorrent 2.0. The same basic principles are at work. So if you have a bunch of users accessing a certain swarm of data, they're going to rehost those files and give pieces out, right? So you're sharing bandwidth, and as a result, it scales automatically, and I'll talk a little bit more about that in a second. The way that we are using this is as a drop-in replacement for HTTP. Okay? Now, we're not getting rid of HTTP, but mechanically, we've added a protocol that functionally is exactly the same as HTTP, but it's peer-to-peer. And as a result, you have this automatic bandwidth scaling because users share bandwidth, but also any device can become a server in an ad hoc fashion. I could use this laptop, make it a server if I wanted to. You use a mobile device, right? Anything. Also, cloud servers, as usual, can access the network and serve on it as well. So let's go back to our diagram of how publishing works on the web. In our model, rather than I want to publish my document here or publish some media or a JSON file or something, I'm going to do it directly. I'm not going to use a server to do it. I'm going to be the server. And somebody that's requesting it will download it directly from my device. Okay? Now, real quick show of hands. Everybody here, raise your hand if you are familiar with how BitTorrent works at a basic level. You've used it maybe. Okay, so like 2/3 of the audience. Okay. So we'll step through exactly what happens. The person on the right, they're the first recipient of the website that we've created, and we've served it directly from our device. Now somebody new comes along, a third party, and they want to download this website. What happens is that rather than just one server, my computer that published the site in the first place, we now have two servers. We have my computer and the computer that downloaded it from me. And the third party could receive those files from either of us or both of us. And this compounds over time so that as new people come into the network, they add in their resources to host files for other people. And it scales up and up and up like that. Now, participation is not permanent. It's going to depend on how we tweak it, but the way it works right now, for a short period after visiting a website, you will automatically rehost it, give back to the person that gave you that content. It's kind of an altruistic concept. And we call this the swarm. And it's kind of like a distributed server. It's like all of us are working together to comprise one server logically. The swarm has some pretty interesting end results. Most of them have to do with cost. Because you are sharing bandwidth with the network automatically, you don't have to pay the cost of all that outbound bandwidth. That's actually one of the most pricey resources for hosting online. It's about 10 times as expensive as disk space. And if you're trying to get to a world where users are able to independently publish websites or content, this actually gets pretty important because you can imagine somebody makes a video and it goes viral. You're talking about a lot of bandwidth. And if you just had an HTTP server at somebody's home, even if they actually manage to handle all those requests, we're talking YouTube kind of scale here. You're talking a lot of requests, a lot of bandwidth being used. They're going to have to pay for it probably, depending on what their ISP situation is like. So the cost reduction is actually an important enabler for making it possible for you to publish information that gets popular and not have to rely on a really big vendor like YouTube to actually shoulder the cost of that bandwidth, right? The network makes it cheap. The other thing that it does, and that I think is actually a little more interesting, is that it makes it really, really cheap to allocate new websites, okay? Because in this network, each website, rather than being addressed by an IP address, like we normally do, you're talking to a computer, instead what we use are public keys. These are cryptographically addressed websites. So you can allocate a new website simply by generating a new random key. It's very easy to mint a new website, and you can make as many as you want.
Sounds like onion sites.
And this really shifts the way that you think about how you build an application. Because now, traditionally, you would think you got your client server, you got a server somewhere, and you're going to put a database up there, and that's how you're going to publish information. Well, now it's very, very cheap to allocate new websites. So why not instead just create a new website and start putting the user data into that website? Anytime you have a new user account, create a new website for it and start sticking the data on there as JSON files. It really kind of shifts up the way that you think about how an application has to be built. I'll step through it in a little more detail here. Before we get into the mechanics of building an app, the first thing I want to make really clear is that it's a file-based data model. It's almost kind of Unixy. We're going back to the idea that everything is a file. All the data in the network is a file. As a result of the protocol, when you go to a site, you can actually ask the browser to show me the file listing. And it'll take you into an Explorer kind of interface, and I'll show you in a demo in a second what this looks like. But you can actually get a full listing of the application or the website that you're visiting. You can see all the files, you can open up the folders and see what's in there, and you can read. And so this is at the core of it. It's all just files, and it's like a bunch of static websites, really. In addition to the DAT protocol for browsing around, there's a web API that we've added, which allows you to read these files and write the files, get the file listings, and also do things like watch for changes on the network, which ends up being really valuable if you want to make real-time responsive applications that sit there and watch these sites for newly published information. Right? Now, I'm hitting you with a lot of concepts, but we're about to wrap it all together. At the moment, the way this works is when you create a site, you become the author. Nobody else can change it. It is bound to your device. Right? So to wrap this all together, let's go by an example. Suppose we wanted to make a Twitter clone. Traditional way to do that is we create a website and a web server, put it up in the cloud somewhere, get a database. A user that wants to get onto our site would access the server and would say, hey, create a new profile for me. The server would say, fine. It would create a new record for you in its database. And then it would publish that information by merit of serving to clients that ask for the information. Right? That's the traditional model. All right, so how would we do a peer-to-peer version of our Twitter clone? What we're going to do instead is we'll ask our application, hey, please make a user profile for me. And instead of talking to a server, it's just going to create a new website for you. Create a new peer-to-peer site.
What?
And inside of that site, it's going to write your information as JSON files. Now the code for this is on your device, right? There's no server involved. This is a peer-to-peer website. All the code comes down to your device. It decides to mint this new website for you to store all of your user data. And now the distribution mechanism.
This is so weird. It's like JavaScript and local databases in your browser. If I try to like find some parallels to systems I understand, because this is crazy. I don't get it.
It's through the peer-to-peer network. And what you're going to find is that the peer-to-peer network is sort of like your new database. Through the files is how you're going to read and write data. So now this is showing it graphically here. You got your peer-to-peer application here, and that's our Twitter clone. And it mints the user profile side, where we're going to put our posts, we're going to put our likes, we're going to put our friends. Any information about what I'm doing on our little Twitter clone is going to live on that user profile side. And all of this is happening on my device. So we don't even have to be connected to the network at this point, right? Because we're just writing files onto my laptop here, and then making it available on the peer-to-peer network, and we can do that later. right? So the writing of the files can happen whether or not we have an internet connection, and we can distribute the files later when the internet comes back on. So here's what that profile.json might look like. It's pretty straightforward. I got my name, I've got my bio, I've got my avatar, my picture, and also I've got a list of who I'm following, right? And included in there is some information about who it is and a URL for them, for their personal peer-to-peer site, right? It's just using peer-to-peer sites and using files. So now you might ask, let's make a listing of people that I know, right? Let's say I'm following 3 people and I want to get a nice list of all of our faces and all of our bios and things like that. Well, first we'll say let's render mine. So we'll access my profile.json. That's already on my computer, so we can just read it, easy. And then we've got these 3 people I'm following. So for each of them, I'll find their peer-to-peer site on the network, and I'll download the profile.json for each of them, right? It's got all the information I need. And then we'll aggregate that information into a table. Maybe in memory, or we can write it to a disk if we want to persist it, so that we don't have to access the network in the future. And then rendering is pretty simple. Just like you would be doing this in a normal application, you're just going to iterate through your table, and you're going to pull the data out and put it on the page. Right? And this pattern has worked well enough that we've actually standardized it into a database that lives in userland, which we call ingestdb. So here you have these peer-to-peer websites, and I'm showing here for the first time a little glimpse of these public key addresses. This is a shortened version. It's actually 64 characters long of these URLs. These have files on them, and so ingestdb says, okay, hey, I know that in the posts folder, if there's a JSON file inside the post folder, that's like a Twitter post. So scan for those, and when you find them, ingest them, eat them up, and put them into a table for us. And we actually store that table inside of indexeddb so that we can run nice, fast queries against them, right? Then let's say you want to make a change to one of those posts, or you want to make a new post. Well, you're just going to write a file, a new post/3.json to put the new post in there. It'll ingest its way back into our table, right? And this is the data model that we've been using for this system to build applications. And I'll show you an example application that does just this. But the idea, again, is that it's nothing but files. Just like in the good old days of Unix. Files are at its core. When you have a record, you just write a JSON file, and that gets published on these peer-to-peer websites. So okay, that's the data model we've been working with. And you know what? Let's just skip these 2 things. I'll get to these later. Let's just get straight to a demo so you can all see what I'm talking about here. All right. This is Beaker. This is version 08. It's not yet released. Let me move it down a little bit so we're not cut off there. All right. So y'all are going to be seeing some stuff that not many people have seen yet because this is all still in development. So we may hit some bugs, we may hit some crashes. Let's hold our breath. Now the basic browsing experience is more or less what you would expect. You can go to traditional websites, you can create multiple tabs. You know, we're doing our best to sort of keep the expectations of how the web works. Let's go over to our web page here. And the first thing that's sort of unique is that we have this peer-to-peer version available tag, right? So we have a mechanism of being able to see when there's a DAT version of a site. So why don't we go ahead and go to it. Now, all you're going to notice changing, if things are working correctly, is this right here. The protocol is going to change, but we have the exact same content being posted on HTTPS that we do on the peer-to-peer DAT version. So, all right, there we go. Yeah, there we go. So this is exactly like you would expect out of the web. Like I said, it's a drop-in replacement for HTTP. So you can navigate around. You use HTML, you have embedded assets, links and things like that. It works completely as you would expect. Where you start to see some more interesting things is over here in the top right. First of all, normally there's a couple of people rehosting this site. I'm interested to see that there's not any, but there's your peer count right there. That's how many people are on the network. I guess I'm lucky. I already had this downloaded on my computer and saved permanently, so I didn't have a problem accessing it. We've also got this control here, where you can start to take advantage of how this peer-to-peer system works, where you can go and view the files. In fact, why don't we go ahead and do that? So here we're inside our Files Explorer. And there is that index.html right there. And we can just browse around and see all the assets involved for this website. Okay? So again, it's all just files. Yeah, go ahead.
So, I'm assuming the binaries for your downloads aren't there, or
Binaries for our downloads.
your electronic.
Oh, right. We're not distributing it on it yet, but at some point we absolutely will put it on there. Yeah.
So would that be your terminal side?
No, it still can work on demand. So you can actually download subsets of a website, individual files. You don't have to download the entire website when you go to a new site, right? So it's a good question, but thankfully, no, you don't have to download it every time. Now, related to that, we also have this control here, which controls whether or not you're rehosting a site at all. And this is a way for us to get into this idea of socially, kind of altruistically giving away bandwidth and helping each other keep your stuff online. And so this is a specific control. Usually it starts out over here. You go to a site, you're not going to rehost it. You'll temporarily give up some bandwidth, but you're not going to keep it online. But you can adjust the slider and say, yeah, I'll give them a day. I'll give back a little bit, or maybe I want to give a whole month, so I'll give a whole month. And that kind of gets the timer going. If we open it back up, it'll let us know how much time is left on that timer. We get a month still, right? So that's a really key part of what we think is interesting about this, is that you can start to really contribute to each other actual resources, right? It's kind of a little bit more cohesive, a little bit more like we're helping each other out. It will stay into the swarm and watch for updates. So the likelihood of you getting stale is pretty small. All right, now I'm going to cheat over here and look at my demo outline. Yeah, right. Why don't I go ahead and create one of these peer-to-peer sites? So again, it's very easy to publish directly from a device, and that allows us to have this cool button right here in the menu just to create a new website. The center interface is a little janky, we're still working on it, but let's go ahead and make our PDX Node PHP site. All right, it just dumped us into our little file explorer. And we're looking at our site here. We're a little crowded for screen real estate, I apologize for that, but here's the site that I created, and by default, it sticks in this JSON file, which is a manifest file. It's including information that I just entered in as well as the URL. Now let's stick in some files here. Let's bring in a picture, let's say. So how about I jump over to the pictures folder and all right, some cute cats. That's cool. So I'll open up the URL here, and I can take this URL, give that to anybody on the network, and they'll be able to download it directly from my computer. File sharing built right in.
That's
Now you'll
convenient.
notice it's a pretty enormous URL we got there. That's 64-character public key. All right. We have the ability to use DNS, which is exactly what you saw earlier. So you don't have to look at those ugly keys. For the most part, what we do is we just shorten it. So it's not too bad to look at, and we'll see, maybe people don't care at all. But okay, this is a website too, so let's jump over to the root resource and see what we get. All right, the file listing. You would expect that out of a website without an index.html. So I prepared an index.html. Let me pull that in. All right, I'm going to refresh the page. There we go. We even got some marquee on there. So I do all that to demonstrate that this all works very much as you would expect out of the web. Oh, there we go. There's a broken interface. Let's see if we can do that. All right, that's good enough. I don't know if you all can quite see that, but this is just HTML. We're just doing an image tag right there, referring to a file on our website, right? Super familiar stuff. All right, back to the cheat sheet. All right. Now we got another application. Let's get into a little bit that data model I was talking about how applications are able to share data in the first place. To do that, I'm going to open up an application that might crash us, so let's give it a shot. Cool, okay, we survived. This is a code editor that we built. Originally, we built this code editor to be a part of the browser itself, but we kind of realized maybe that's not the best idea. It was getting a little bit large, so we moved it out to userland. So now this actually lives in as an application. This is a peer-to-peer application, okay? And what it's going to do is use web APIs to read and write files and provide a nice kind of code editor experience, a little bit like a light IDE. And in fact, we're using the Monaco editor, which is what VS Code uses. So it's actually a pretty nice piece of software. So let's open up our site that we just created there. All right, there it is, right? There's our little PDX Node site. Why don't we open it up again? Now let's make a change. Let's, that marquee was a bad idea. Let's get rid of that. And let's add a few more exclamation points. All right, now hit Control S. Now it's going to have to ask permission because it's about to modify another site on my device. So of course you want it to ask permission for that, but I'll go ahead and allow it. Go over here and refresh. There you have it, right? So it's all kind of like a universal web file system that we're working with, okay? Should be pretty intuitive. Now let's see if, we have a live reloading tool. Let me see where that's at. Yeah, all right. This may work. As you can see, I got a little lightning bolt here to indicate. What I did is I just turned on live reloading through our tools up here. This should be possible. You should see this thing reload without me having to touch anything. Well, that's in question there. All right, there it went. Neat thing about that live reloading, to your question earlier, is that that works over the network. Because whenever you enter into the swarm, you're going to sit there and you're going to put out a UDP packet once every, I think, 5 seconds. Not a whole lot of bandwidth, but you're sitting there asking, anybody got something new? And by and large, nobody will say anything. But if there is something new, it'll come down, and the browser can actually recognize that. If you got live reloading on, it'll reload the page for you. Just a kind of a neat thing that we found, hey, we could do that. We have access to that information, so we threw it in. All right. One other kind of cool thing about this data model can be demonstrated with the WYSIWYG. And what you see is what you wiki. Not only can you edit other websites with these APIs, you can actually do self-mutation, which may actually be a really bad idea. But we did it anyway. So let me make a copy of this site. Now forking is just like in GitHub. You can actually go to any site you want and say, fork this thing for me. You're going to download all the files, you're going to create a new site, copy the files over, just like that. You now have a version of the site that you can edit. All right? Putting stuff in people's control, that's the idea. So let's do PDX Node wiki. Create our fork, this happened fast. All right, done. Hit the edit button. And let's get some cool styles on there. Hit the save button, and we did it. We just mutated the site using its own code. Using the WYSIWYG controls inside of there, we just wrote to the source code of it and changed the content. So actually, why don't we jump over to the File Explorer and look at the index.html. Am I going to be able to? Well, I apologize. I went and broke our view source tool, so we can't see it. But inside of there, you would find that we actually just modified the index.html. Just wrote directly to itself. Why not? We might at some point have to rein that back. We're not really sure what the security profile of something like that's going to be. But for now, we figured it's kind of cool. Makes it easy to make nice, self-modifiable websites for a wiki like that. It's actually a pretty handy use case. All right. Now let's bring it all together with one last idea. Earlier, I was talking about the JSON records and sitting there and watching them in ingest DB. Well, after writing that for applications, we actually realized that we wanted to put some application features in the browser itself. So ingest.db is inside the browser as well. And we've used that to implement some application style features in the browser, starting with the ability to create public bookmarks. And apologies to the guy from Penboard, but we've just been ripping off all of his good ideas. We've got tags on the bookmarks. We've got notes, so you can say why you bookmarked it in the first place. And you can see here, I'm following my co-founder, Tara Vansel. And I can narrow down to the bookmarks that she's made public.
She.
So each of us has a
There's a
personal
she.
site, a sort of a
There are no girls in the internet, so if there's one she, that's probably she who made the other talk I was listening to. Or I was tripping that. I'm not sure if I've seen her talk about this browser already, but I feel like might be her.
profile site that's automatically generated for you when you first run the browser. And that is where we're publishing these bookmarks. So I can jump over to a new site. Let's find some random link on Hacker News here. Cool, that sounds great. Let's share that with the world. So you just go down to this control and make it public. And there you go. And what just happened, let's head over to our file browser here. Let's go to my user profile. And my bookmarks, I was under Bloomberg, so there it is right there. There's the bookmark that I just published, just as a JSON file on my profile side. Now let's look at that site structure again real quick. This is exactly what I was talking about a moment ago. I've got a profile.json with my name and my bio and all that information about who I'm following. And then underneath the bookmarks folder, we have these JSON files, which are all my publicly published bookmarks, right? So hopefully you kind of get an idea of how these applications work and how this is what's going on underneath, just files. But through that, we're able to build applications that have the kind of features you would expect out of the web.
Probably a bad idea.
We're planning on taking this to the point where, first of all, you can have sites that you publish in sort of like a shared wide area network file system. Where you can see I'm following Tara, so she's actually in my file system. And I can look at the things she's published, and we're going to narrow these down by type, so you can have applications or music album sites and things like that. And then perhaps we can even get into an idea of helping each other automatically host the content that you publish, like your profile and things like that, so that we never need servers at all. If you have a good 10 people following you and contributing bandwidth, then by and large your social network should stay online by the merit that 1 in 10 are probably going to have their computer on, right? And we think we can take this pretty far before we release OA. We're probably going to put in a timeline as well, so you could do the equivalent of a tweet inside the browser and things like that. All right, so that wraps up the demo. Let me just wrap this all up with a really, really highly biased timeline of the web, both past and future. This is kind of fuzzy, but we'll go with it. You look at the 90s, you have what I'm going to call the academic/hobbyist web. It's kind of ugly. It was cool, everybody was into it, and some pretty amazing things happened. Amazon and Google for sure happened at that time, and Yahoo was pretty amazing when it happened too. But it was also kind of, it was a web that only its mother could love. You had to be thinking big to really care about it. Around 2000, we got kind of more Web 2.0, right? That's when we had Ajax happen, HTML5 happens. Things get really, really commercialized at this point. And it's actually, if you think back on it, it was pretty amazing to have some of the new products coming out. Like, I was in maybe high school and we were printing out MapQuest maps, and that was just like the biggest thing in the world. It's easy to forget how exciting those times were. Especially because after 2008, it kind of slowed down. By 2008, we kind of stopped experimenting as much with social stuff, started to be more about sharing content, so stuff like Pinterest and Imager and some of the different media platforms kind of took off. And really around that time, these three guys won the show. And that's why I would consider this the corporation-driven portion of the web, where they are deciding what we're going to do with the web platform for the most part, not so much Amazon, but definitely Google. What we're going to do with the web platform, what we're going to do with our software, and of course Facebook sets the content experience for most people on the web. Most people actually just think of Facebook as the internet. Okay, so where's this going to go next? I'd love to have this be 2017, but let's give us 3 years of cushion before we can have this happen, where we move away from a corporation-driven mechanism and into a consumer-driven web, or perhaps a little bit more high-mindedly, a more democratic web. Because if we're able to put control over the software and of the data into the end-user devices, then we should be able to move to a model where rather than having businesses build all of our applications for us, we can get really open source with it. We can let users build applications from the ground up, change things to fit their needs, and as long as everybody has a fork button in their browser, they should be able to express their preference for where they want their web experience to go. So that is where I think we ought to be taking this, both giving people more individual control over what they're doing, but also at the same time solving some of the pressing privacy problems that the web has now. And in addition to it being peer-to-peer, I think we can get some end-to-end encryption involved and really lock up some of the deficiencies for how we share data. So that wraps that up. You can check out what we're doing at beakerbrowser.com. 08 will probably come out within the next 2 months. We're not putting a hard timeline on it because we don't want to make sure we really like what we're doing. So that's going to be somewhere in the next 2 months, so feel free to give it a shot, and you can find us online all the time. Feel free to hit us on Twitter, and we are there to talk to you. So thank you all very, very much for listening.
Okay, that's it. Oh, questions. Tons of questions.
Questions for Paul. I'm sure you do.
Yeah. Yeah. So he's asking, if somebody creates a new website, how do I find the computer that created it? How do I get access to it in the first place? That's what we call the discovery process. You're trying to discover your peers. We have multiple overlapping tools for that. Multiple overlapping networks. First of all, if you're on the same Wi-Fi with somebody, we have multicast UDP. Okay? Do you know what I'm talking about? So, what's that? In this case, we're not. Okay. If you're not on Wi-Fi with each other, we have what's called a distributed hash table. It is a kind of a flexible living registry where you talk to one of the bootstrap nodes and you register yourself as participating in it, and then you start to broadcast what you have available. So it's not a server. It is a flexible system where nodes can come in and drop off at will. We do have to use what you call a bootstrap node, right? Somebody that is permanently a part of the network, but they only give you the first pointer to where you need to go. And then after that, their involvement is relatively minimal. There's some amount of infrastructure that you absolutely can't get away from, you know. Yeah. It's an astute question to ask, and you know, there's a bootstrap, but the whole point is to minimize the amount of responsibility that's invested in those bootstraps, so that we stop depending on them. They do their job and don't control anything else. Right? It's very similar to a tracker. Yeah. The DHT is sort of a distributed tracker system. Yeah.
What characteristics made DAT best candidate?
So he asked what characteristics made DAT the best candidate. If we had done this project 10 years ago, I would have just used BitTorrent. Since DAT is available now, it gives us some improvements that are pretty positive. One of them, the most important being that it can actually support changes to the archive, or torrent if you're using BitTorrent's parlance, right? So it's mutable. The other alternative that we seriously considered is IPFS. They're both good technologies. There were just a couple, it was kind of like, well, we have both available and they're both good, so which one do we like a little bit more? But honestly, most of the work that we're doing here could be done with IPFS as well, and they're doing good work. So it's almost just kind of how it fell out. We may end up bringing IPFS back in, but we're just not sure if there's any point to doing that if we're getting all of our needs solved by DAT. So.
You got a question? Okay.
Yeah.
For us, I think
Yeah. Yeah. So he asked, how does the DNS work? And pointed out that those URLs are way too big for most people to work with. And there's no doubt, like, you're never going to remember that. You're never going to be able to eyeball it and know that you're looking at the right place. I think there may be use cases where those work out just fine. An example that's similar would be if you make a sharing link in Google Docs, for instance. we're used to having those garbled links for some cases. But you're right that we do have to have a good short name system. The way we're handling it right now is a little bit of a hack. We're relying on DNS, but the problem with DNS is that DNS does not have an authentication mechanism. You can't trust a DNS response by itself. You actually have to use something like HTTPS, right, the SSL certificate, to verify that a DNS response is correct. But we don't have HTTPS, we don't have certificates in our system, so we are not able to do that. The solution that we came up with was to bootstrap in a way off of HTTPS. So this is the hack. You go to beakerbrowser.com, which is the site that I showed earlier using the DNS. You go to, go to this address here, this well-known address. You're going to find a file, and this file is basically a DNS entry turned into a file. Let's see if I can find it. Here we are. Okay, so at https beakerbrowser.com, at a well-known path, .wellknown/dat. Can I zoom this guy? We have all the information we need to do the lookup, so that whenever we go to dat, beakerbrowser.com, in the background, Beaker's going to access this HTTPS URL and pull down this file here, right? And it's going to say, okay, there's a DAT file there, and it has a raw DAT URL inside of it, and a TTL telling us how long to cache it, just like you would expect out of DNS. Access that peer-to-peer site, right? So we're bootstrapping off of HTTPS for the moment. Obviously, that's not how this is going to work in the long run, but we're kind of in the place where that's not the right thing to think about. We just need something that works, that's trustworthy, and so this is what we've gone with now. Coincidentally, this exact mechanism is also how we were able to go to https beakerbrowser.com and know that there's a peer-to-peer version available. We optimistically do that lookup, and when we see the record, we say, oh, okay, there's a DAT version. Yeah, he asked how is Hashbase involved. Hashbase is a service that we put together that is basically DAT hosting in the cloud. We're still debating exactly how we're going to work with Hashbase. Like I was saying earlier, it's going to be a lot more fun if this all has the kind of magic no server attribute to it. So we put together Hashbase based on the fact that sometimes you need to have a site stay online. For instance, we need the DAT Beaker browser site to stay online. So it would be good to have traditional hosting, something in the cloud that you can rely on so that you can turn your laptop off, right? Because you always need a seeder. You need somebody to host the thing. So the premise was, okay, we'll make a service. They can rehost your DATs for you. And we're okay with it. We think that there will probably be a future for it, especially for any commercial publishing where you just have to have total confidence that your stuff is online. But for the most part, what we're now are hoping is that through the social networking mechanism, we can actually make it so that most people would not have to use something like Hashbase for their daily experience. So that's where we are with that.
Yeah, what's the most compelling use case that you would use this peer-to-peer browser versus just regular for, say, application?
For my money, I think Office software may be the best place. Google Docs and Excel competitor. The reason for that is that not only is Office software a relatively peer-to-peer transaction, you're mainly sharing files and messages between computers in an office, so a small group of people transacting with each other directly. That's one reason, but the second reason is that security is actually relatively high value to anybody doing office work. You don't want your intellectual property leaking out. So to be able to have an application that doesn't actually require the cloud at all, that's basically on-premise, but without any kind of local configuration of a server, I think that's a really big benefit.
And one more question was, how much disk space is being used? If you're sitting around
If you download big things, plenty, we'll have to basically be smart about how we manage that. We're going to, in this is actually something that all browsers deal with. Whenever they have local storage or indexed DB, they have to manage a quota.
Yeah, that's
about
what
how
I
much
meant,
they
index
allocate,
DB.
and they do that on the basis of actually how much disk space is available. And we're going to have some amount of high-level reasoning put in to say, okay, you know what, this computer's getting a little swamped. Let's delete some of these things. Let's stop rehosting a few things. It's definitely going to be a balance. And if we're starting to degrade the performance of the computer, then we're failing. So there's a balance that we'll strike, and right now it's unrefined, but it's conceivable that it can be done.
I'll be the jerk and ask, can you sketch out what it looks like to offer a commercial service? So, for example, you mentioned the Office doc apps, for example.
Yeah.
So what would it look like if I create something for sale, monthly recurring fee?
Yeah. That's a good question. He was asking, how does basically the economic model work for somebody making a peer-to-peer application? How do you monetize that? Because it sort of is messing with the SaaS model, right? SaaS binds an application to a specific server resource, and that simplifies, I think, how we pitch the sale to people. If you go into a peer-to-peer system, you actually are getting to the point where you might have to sell software by itself, and software by itself doesn't really sell that well right now. So I think it's actually a valid question.
So back to the future kind of thing where you're buying an app.
Yeah, exactly. I mean, I don't know if there's any future where you reconstruct the app market for the web. It's kind of one of those things where we're going to have to worry about that later, right? Can't answer all of those problems. But I will say there is one kind of mechanism you can do, which is you can have a DAT service where you sit there and watch somebody else's DAT, and as changes occur to it, you do processing and emit the output into another DAT for them to download. And in fact, we're going to have a version of the protocol in the near future that allows multiple people to have write access to an archive so that it can be kind of a collaborative thing. You can both write. And so it's conceivable, perhaps, that you can make services which do heavy processing and output the information into a DAT, and it remains in the peer-to-peer network. I don't know if that's really a great answer to what you're looking for, but I mean, you're right, it does mess with the SaaS model. Yeah. Yeah, he's asking how much, I suppose, redundancy do you need to have for a website to provide a reasonable expectation of uptime? I actually can't answer that yet. I could make a guess, but it's going to depend on how the social system pans out. And at the end of the day, right now what I tell people is if you have something that you must have online, that you can't ever have a 404, then you need to set up a cloud process somewhere and keep it online in a really sort of a traditional way. But that doesn't, I don't think, diminish the value of this system because it still makes it possible for end users to do independent publishing without having to necessarily do that in the first place. And if we can get 90% uptime, then for most people transacting, if you have like a 10% of your day from 2 a.m. to 4 a.m. where none of that stuff is available to you, that might be, it's a start. And we'll see where it goes from there. Yeah.
You mentioned something about certificates and how that's not something you do right now.
Yeah.
Can you sketch like a basic picture of how you see something like PDX over back?
So he asked, we don't have anything like SSL certificates, and could I sketch out an idea of how that might actually come into play with this? How might that work? I can't give you too good of a sketch because really you need to have a crypto engineer take that seriously, and that's not my specialty. I think it's conceivable that you could have an SSL or a certificate of some kind issued and then written to a place in the site that's a well-known URL, so /certificate.syrup, whatever. And that may end up being a perfectly reasonable solution. But I haven't gone deep enough to really give you a great answer on that. Really, the bigger problem is actually getting the certificate authorities to exist for this technology. And that's not going to happen prior to some amount of adoption in the first place. So for now, the question is punted. We're just going to bootstrap off of SSL to get the DNS short names, and that's what we'll go with for now. Does that make sense? Yeah.
So there's no way to hide information if I make one of these URLs available. Let's say we take this office scenario and describe it, right?
Yeah,
I
yeah.
want to make something open available to my codec.
Yeah.
How can I even, like, I'm not sure what layer some protection would be.
So he's asking, how could we have, I suppose, end-to-end secrecy in a system where if you have the URL, you're able to access the files, right? And the answer to that is going to be, we're going to be using the URLs. Again, these are public keys, and we have user identities being represented by these sites. So this right here, this string that starts with the 1.5 there, that's my public key. And you can encrypt files using my public key so that only I can decrypt them, right? So on the basis of this social network that we're creating here, where I'm following people, these URLs of who I'm following are also sort of a web of trust signature. Because what I'm saying is I at least believe that's Tara Vansel and I'm following her. So I have some level of confidence that I actually got the right public key for her. So that's sort of an identity signal that you can work with. And so from there, we can begin to build out the sort of public key infrastructure necessary to do end-to-end encryption, where you encrypt a file entirely before you write it to the DAT. And that's how you can have a very, very high, level of certainty that you're keeping your stuff secret. Yeah. You all have been awesome. Thank you very much.
Okay, that's it. Actually, this time. Why I use the staircase? Whatever. Yeah. Go check out the original video I watched in the background, and go check out Lasergurkenland.